Hello everyone. In this video, we'll talk about the idea of the reorder point. So in the last few videos, we looked at the economic order quantity model, the production order quantity model, and the quantity discount model. Now, the main question these three models answer is when you're managing an inventory system on an ongoing basis, how much should we order? That's the main question all of these three models answer. But there's also another important question that I sort of posed towards the end of the quantity discount video, which was when do you place the next order, right? Because we are assuming, so in the economic order quantity model and the quantity discount production order quantity model, we assume that demand is known and fixed, and you order demand on a continuous basis. So you know exactly what your demand is. So you sort of manage a cycle in such a way that as soon as your inventory becomes zero, you place the next order so that you're not holding too many items in inventory, and then you sort of manage the cycle, right? So this is what the economic order quantity cycle looks like. If you remember, this the EOQ cycle looks like this. Quickly, right? So you're managing everything so that as soon as your inventory hits zero, the next order arrives, and immediately inventory becomes capital Q, inventory becomes zero, goes back to Q, and so on, right? So that was the economic order quantity cycle. And then the production order quantity cycle was slightly different, because in the first part of the cycle, you are manufacturing and using items at the same time. You're manufacturing at a faster rate than your demand. Otherwise, you'll never accumulate any inventory, right? So assuming that you're manufacturing more, at a faster rate than selling the items, your inventory increases till you stop manufacturing, and then there's a selling period. As soon as inventory becomes zero, you set up the next cycle, and then you repeat, right? So again, all of this is under the assumption that demand is known and fixed, right? And even within the economic order quantity model, when demand was known and fixed, if we assume that there was a lead time, a time between placing the order and the order arriving, right, then you had to calculate the reorder point. So the reorder point was demand per day times the lead time in days, right? So demand per day times the lead time in days, and demand per day can be calculated as annual demand divided by number of working days in a year. Right. So we did an example. We said that the daily demand, if annual demand was 8,000 with 250 working days in a year, daily demand would be 32. And then reorder point would be daily demand times lead time. So if lead time was 3 days, reorder point would be 96. If lead time is 32 days, reorder point would be 128. But what exactly is the reorder point? So if you go back to this economic order quantity cycle right here, what you do is you keep a tally of inventory as the days go on. Now your inventory starts at capital Q, whatever your capital Q, your optimal order quantity is, and it slowly you start using it. At some point, if 32 is your reorder point, as soon as your inventory level hits 32, you know that you have come to a point where you have just enough inventory for you to last your lead time. So your next order gets triggered, and then as you keep using inventory, as soon as the inventory reaches zero, the next order arrives. And we are able to choreograph this perfectly because we know that demand is used at a constant rate and everything works exactly as we planned. But what if that's not the case? What if demand is variable? That is the major assumption of the economic order quantity model. What happens if we relax that assumption, right? Now, before I proceed, one last thing I'll talk about the quantity discount model is that remember that even with the quantity discount model, all we're trying to do is find this value of Q, right? We look at multiple options for Q, then we calculate the total cost using the setup cost, holding cost, and the product cost. We look at the multiple options that we had here, and we pick one of the options. So we have multiple options, we pick one of the options, and we go from there, right? So that's the idea behind the quantity discount model, right? So keeping that in mind, coming back to what I was talking about. So what if demand is variable? What happens if demand is variable? So if demand is variable, right? So demand is used at a variable rate. It doesn't go down as a constant number. It sort of goes down sharply sometimes, doesn't go down in some time periods, and so on. So even in this case, let's say that you have a certain reorder point. Now this reorder point might be fixed, it might not be fixed, whatever. So you've decided on a certain reorder point. Now till your demand reaches the reorder point, the next order doesn't get triggered, right? So the whole idea of the reorder point is that is the point of inventory where the next order gets triggered. So we have to decide the reorder point based upon what our demand looks like. Now, if a demand was constant, we would choreograph it in such a way that you would place an order in such a way that your demand would arrive just as your inventory is going to become zero. But what if demand was variable? So what you do is, when demand is variable, you calculate that point. So instead of looking at fixed daily demand, you look at average daily demand, right? So you say that, well, we look at multiple cycles of this happening. What was the demand during the lead time? So if you ever are going to run out of inventory, it is this lead time right here. It is this lead time that you're going to run out of inventory, because till this point, till the reorder is triggered, you still have inventory on hand, right? Reorder point is a level of inventory. So if reorder point, let's say, is 350 or 366.5, whatever that number is, once you have a reorder point, till you reach the reorder point, you have inventory on hand. So you're not going to run out of inventory. But once you reach the reorder point and the next order gets triggered, by the time the next order arrives, during lead time, that is when you are in trouble. That is when you are potentially in trouble. If you do not have enough stock and inventory, you could run out. There is a potential for a stock out, right? And that's what we are trying to figure out in this model. So if you're going to answer the question, when should the next order be placed, it will be based upon how often do we not want to run out of inventory. And if you might say, well, we never want to run out of inventory, that is not always true, because holding inventory costs a lot of money. So if you have to turn away a few customers so that your costs are reduced, that might make more sense. And that's what we'll talk about in this model today, or in these series of models today. All right. So what we're going to talk about is this time during the lead time, when we are in peril of running out of inventory. The time before the reorder point, nothing happens because you still have inventory on hand and the reorder has not been triggered. But once reorder is triggered and you know that the next order is going to arrive in a certain amount of time, you have to have enough inventory to cover most of the time or most of your customer orders, right? And that's what we are going to do. So we are looking at this lead time, and we're going to assume that the demand during lead time follows a normal probability distribution, right? So when demand is probabilistic, what we do is we prescribe service levels to set safety stock when the cost of stockouts cannot be determined, right? So sometimes cost of stockouts can be determined, and then you have a different method. I'm not going to go over that. It's in the textbook. You can take a look at that. But in most real life scenarios, it's very hard to figure out what is the cost of a stockout, right? I mean, you can calculate the monetary value, but imagine somebody goes to a grocery store and they want to buy Cheerios. They go there, they don't have Cheerios. Then it's in your mind that this grocery store likely doesn't carry Cheerios or doesn't have Cheerios on a regular basis. So if you want to buy Cheerios, very likely in your mind, you're not going to go back to that store. So you have lost that customer for life potentially. So stockouts can have tangible costs that you can calculate and can also have intangible costs that you cannot calculate. So assuming that there are these intangible costs that you cannot calculate, what is usually done is you prescribe service levels. So service levels are something that is common in a lot of industries. Anybody who's ever worked in, say, a call center would know that call center have service levels which say that a certain number of customer calls have to be answered within a certain amount of time. So you have a 3-minute period and 95% of the calls have to be answered within 3-minute period. If you don't, then there are some penalties and the company takes a hit and so on. So there are lots of different issues there. So service levels are very common in the service industry and also in the retail industry. So what is a service level? So service level is the probability that you will have stock when a customer comes to your stock, that there is no stock out. So if you say that you have a 95% service level, you're saying that there is in 95% of periods, you did not have a stock out, but there is a 5% chance that you might have a stock out. So in any given period, there's a 5% chance of a stock out and a 95% chance of not stocking out. That is what you mean by a service level, right? So in many of these cases, when you have these probabilistic demand values, when you don't know exactly how demand is going to come down, during lead time, what you do is you calculate your, you have a service level set, and for this service level, you calculate something called safety stock. Now, if demand was constant, you would have a fixed reorder point. Now that fixed reorder point is calculated as daily demand times lead time. So you calculate average demand using the same formula. You calculate it as daily demand, average daily demand times lead time, right? So that's your average, that's your average demand. And then you add an extra layer of protection because you don't want to run out of inventory, or you have extra stock on hand so you don't run out of inventory, and that is called the safety stock. And so the whole idea of probabilistic demand is figuring out what is the optimal level of safety stock. And this optimal level of safety stock depends upon what service levels you have set for yourself. Once the service level is set, safety stock is also set, right? Let's see how these numbers are calculated. Now, before we proceed, there are two things that I want you to understand. One is that demand can be variable, like we talked about, but the other thing that can be variable is lead time itself. Lead time is the time between placing an order and receiving an order. So imagine you go on Amazon and you place an order, right? When you place an order on Amazon, if you have Amazon Prime, you have a fixed lead time. Everything comes to you within 2 days, right? But if you do not have Amazon Prime, you're buying something from somebody on Amazon who does not participate in the Prime program, then lead time can be anywhere from, say, 3 days to 5 days. Or it might be from 3 days to 10 days or some random number like that. So lead time itself can be variable. And in real life, when you're ordering from your vendors, when you're ordering from third-party suppliers and whatnot, lead time being fixed is very unlikely. In most real-life cases, lead time tends to be variable because things happen, right? And so what we'll do is we'll first look at examples where we'll assume that lead time is fixed, and then we look at examples of what happens if you assume that lead time itself is variable, right? So the important piece here, as I said, is the lead time itself. So we need to figure out what is the demand during the lead time and what is the variability of demand in the lead time. Once we figure these two things out, then we can answer a lot of these questions, right? So what we need to do is we have to calculate the average demand during lead time, and we have to calculate standard deviation of demand during lead time. So if you assume that the average demand during lead time is 350 kits and standard deviation of demand during lead time is 10 kits, and let's say that we have a stockout policy of 5% or a service level of 95%, then we can calculate the safety stock. So how do we calculate safety stock? Well, we can calculate the safety stock by taking 95% as a probability and using the normal distribution table. So you can either look it up in the normal distribution table, or as I will show you, you can use Excel, right? So let's look at this example. So where is this example from? This example is from textbook, so that's fine. I'll look it up for you guys in a second. All right. So reorder point, instead of being calculated just as the expected demand during lead time, to the expected demand during lead time, you're going to add the safety stock. And safety stock is Z times the standard deviation of demand during lead time, like I just said, right? So let's see how this calculation is done. Let's say that we open up an Excel file right here. So if we say that we make the font bigger so you can do some of this calculation. So demand during lead time, right? So we say average demand. I'm going to call it DDLT. That's average demand during lead time. So, and standard deviation of demand during lead time. There was a famous Hindi movie called Dilwale Dulhaniya Le Jayenge. That's not DDLJ, it's DDLT. Same. All right. So 350. So we say that the average demand during lead time is 350, and let's say standard deviation of demand during lead time was given to us as 10. Right. So that's really tiny. But anyway, and then we say that service level is, let's say, 95%. Right. So then we can calculate our safety stock. We can calculate safety stock as standard deviation of demand during lead time times the, so it will be norm.s.inv. So this is the standard normal distribution. So mean of 0, standard deviation of 1. So it's a standard normal distribution. And we will use this number as the probability. And we're doing the inverse calculation because we are using probability to find the value rather than using the value to find the probability, right? There you go. So that's your safety stock, 16.5 60.45. So I'm gonna just show a couple of different places. 60.45. In fact, you know what we should be doing is that when you calculate safety stock, you should always round up. So I'm going to use the function called round up. So what does round up does is it always rounds up to the next integer. So you should always be rounding up. You should never round down. So let's say round up, and we'll say comma 0. Why comma 0? Because that's the number of decimal places you want to round up. So let's say that if I said comma 1, then this formula will round it up to the first decimal place, 16.5. But instead, I do not want any decimal places. And the reason for this is we are looking at kits. If you're looking at kits, half a kit doesn't make sense. So your safety stock is 70. All right. So once I have the safety stock, I'll now say that the reorder point is the average demand during lead time plus the safety stock. Now, why is this useful? Because in the previous case, when demand was fixed, right? When demand was fixed, you would just calculate demand during lead time, or you would just calculate average demand, right? So daily demand, for example. You'd calculate daily demand, and daily demand would be a fixed number. There is no variability in it. And that fixed number is what you multiplied by lead time to calculate your reorder point. But that's not the case here. Now, the important thing to remember here is that this 350 and this 10 is the demand and standard deviation for the whole of the lead time. So let's say lead time is 10 days. You're saying that over those 10 days, on average, demand is 350 and standard deviation of demand is 10 for all those 10 days put together. Okay. Now, but what if we don't have data for all 10 days put together? What if we have data, let's say daily demand data? So let's look at that. Okay. That's the idea. So 16.5, so 367 kits, right? Like 17. That's what we do. All right. So what if we know what daily demand is and not the lead time itself? So let's say that instead of saying that demand during lead time is 350 this way, let's say that this is the data that I have. So I'm gonna, you know what? I'll say DDLT is given. Let's say DDLT is calculated. So I'm just gonna make a copy of the sheet, create a copy. So let's say that daily demand and standard deviation of daily demand. Right. So let's say that daily demand is, let's say daily demand is 35, right? Let's say standard deviation of daily demand is, okay. Standard deviation of daily demand is, let's say 3.15, right? Let's say standard deviation of daily demand is 3.15. I just want to check something. I'm going to pause this video. I'll be right. Right. And one last thing is, let's say the lead time is 10 days. Right. Now, so if daily demand is 35, standard deviation of daily demand is 3.15, and lead time is 10 days. How do we calculate? So the average demand during lead time and standard deviation of demand during lead time are not known. How do we calculate these numbers? So the average demand during lead time, so you say that every single day demand follows a normal distribution with an average value of 35 and standard deviation of 3.15. So if that's the case, the average over all 10 days, because that's what you're trying to figure out, demand during the whole of the lead time. Average for the whole of the 10 days will be 35 times 10. That's the average demand. But for standard deviation, it's not going to be as simple. Standard deviation is going to be 3.15 times the square root of 10. Now, why the square root of 10? Because if you remember from project management, we talked about the fact that you cannot when you are adding multiple probability distributions, you cannot directly add the standard deviations. You can directly add the variances to be the variance of the sum of the random variables, but when you're doing standard deviations, you're gonna, if each of them is the same, you're gonna multiply them with the square root of the length, and that's what you're doing here, right? There you go. So this is 9.96, so it's close enough to 10 that we had here, but that's essentially there. So let's say that's, if it's just 3.16, so that fix that. Yeah, that's better. Okay. Right. Right. So if you assume that standard deviation of daily demand was 3.16, so this is given to you. So you're given that daily demand is 35, standard deviation of daily demand is 3.163, and lead time is 10. Using these numbers, you can calculate the average demand for the whole of the lead time and standard deviation of demand for the whole of the lead time. So these numbers can be calculated. All right. Now, in this case, these numbers were given. So if the numbers are given, you can calculate the safety stock in a straightforward way. But if the numbers are not given, you first calculate the average and standard deviation for the whole of the lead time, and then use those numbers to calculate the reorder point. All right. So that's the first thing. So this is the example where demand is variable, but lead time is fixed, right? But let's see what happens if that's not the case. What if lead time itself is variable, right? So let's look at another example. Right? So these are the ones. So demand is variable, lead time is constant. We looked at that example. So we can also look at a case where lead time is variable, but demand is fixed, right? So lead time is different, but demand is fixed. And then both demand and lead time are variable. So let's look at all three models. So let's look at the case. So we looked at the case when demand is variable, lead time is fixed. Let's look at the case where lead time is variable and demand is fixed, right? So if lead time is variable and demand is fixed. So this is the case where lead time is fixed, but demand is variable. So that's why you have sigma D, which is the standard deviation of daily demand, right? Now, if you assume that, so if you assume that lead time is variable, but demand is fixed, right? So daily demand is a given number. So you take the daily demand, you multiply that with the average lead time. And to that, you're going to add safety stock. And safety stock is just daily demand times the standard deviation of the lead time multiplied by the corresponding inverse probability. All right. So let's look at this example. So in this previous example where we are assuming that lead time is fixed, but demand is variable, we are assuming that average daily demand is 15, lead time is 2, and standard deviation of daily demand is 5. And we want a service level of 90%. If you want a service level of 90%, if you use the norm.s.inverse formula, you will find that the z value corresponding to that is 1.28. Now here in the textbook, I think they ask you to look up the tables, but you don't need to look up the tables. You can just use the standard deviation. So it's a 15 times 2. So when you're calculating the reorder point, first you calculate demand during lead time. So this is the total demand during average demand during lead time. So average demand is average daily demand times the lead time. So 15 for the first day, 15 for the second day. So the average demand is 30. That's the first part. Next is the safety stock part. So the safety stock will be the z value, which is 1.28 that we calculated, times the standard deviation of daily demand. Standard deviation of daily demand is 5. And you multiply with the square root of lead time. Square root of lead time. So again, we are doing square root of lead time because lead time is variable. The lead time is fixed. It's not variable. So with that, we'll get 39.02. So in this case, I guess they're rounding down, but my suggestion is to always round up because it's better. And then get a safety stock of 39 or 40, depending. So safety stock is 9, average demand is 30, and so your reorder point is 39. So what does this mean? This means that you'll keep looking at your inventory, keep an eye on it, and as soon as your inventory reaches 39, you trigger the next order. Now, your order might arrive either before or after all your computers are sold. So it might arrive when you have, say, 5 computers left over, or it might arrive when all your computers are sold. You have a stock. Or no, both are possible because demand is variable, right? But what you're saying with this 90% service level is that during any lead time, there is a 90% chance that you will not run out of inventory. That any customer who walks in, there's a 90% chance that they will find some computer with them. So you're okay with about 10% service level loss, but but 90% of the time there'll be somebody. So to keep that service level at 90%, you need a safety stock of 9 computers, and totally you need a reorder point of 39. So your demand goes down, as you keep selling computers, and as soon as it's 39, you trigger the next order. And then by the time the 39 computers used up, sometime the order will arrive, and then this whole cycle will continue. That's the basic idea. So this is when lead time is fixed, but demand is variable. But what if, look at a case where constant demand and a variable lead time. So we say that daily demand is exactly 10, right? But the average, so lead time is variable with average lead time being 6 and standard deviation of lead time being 1, right? Let's say you want to set a service level of 98%. You do the normal inverse for 98%. It comes out to be 2.054. So norm.s.inv will give you 2.054. Then you can calculate reorder point again. So demand is 10 times the average lead time. So 10 times 60. So that's the average. If there was no variability in anything, this would be your reorder point. But because lead time is variable, you're going to add some safety stock, and the safety stock will be the z value that we calculated. Multiply that with the standard deviation, and this time, multiply that with the length of the lead time, which is average daily demand 10, and then you multiply that with the standard deviation of lead time, right? So that's the formula right there. Hang on. Right. So yeah. So the safety stock formula is z times daily demand times the standard deviation. That's what you do. Z times daily demand times standard deviation. Right. Now, the other probabilistic model. So the final model is where both lead time and the demand are variable, and this is the case that is most likely true in most real life cases. So then what you need to do is you have to calculate the demand during lead time. So you have to calculate the average demand during lead time, and you have to calculate the standard deviation of demand during lead time. Now the average demand during lead time is easy because you multiply the average daily demand with the average lead time. So look at the average and look at the average and just multiply the two numbers together, you'll get the average demand during lead time. So if there was no variability, that would be your reorder point. But because lead time is variable and demand is variable, you have to calculate the standard deviation of demand during lead time. So this is the standard deviation of demand during lead time, a lead time which itself is variable. So variability in demand, variability in lead time, you put that together, and this is the standard deviation formula. You take the average lead time, you multiply that with the square of the daily demand. To that you add average daily demand square times the standard deviation of lead time square. So you see that the average lead time here does not have a square, but everything else is squared, right? So keep that in mind. Then you calculate this and you'll get, this is the standard deviation for the whole lead time. When both the lead time is variable and the demand is variable. And you calculate that, you multiply with the z. The z value is based purely on your service level. You set it at 90%, it'll be something. You set it at 95%, it'll be something. So those numbers are fixed. They do not depend upon any of these things. It just depends upon your service levels. So if you assume that the average daily demand is 150 with a standard deviation of 16. So per day, demand is 150 with a standard deviation of 16. Lead time itself is variable. The average lead time is 5 with a standard deviation of 1. And if you assume a service level of 95%, so you have to calculate the reorder point. The first part of the reorder point is the average value. The average value is you multiply the average demand, daily demand, with the average lead time. So on an average, demand is 150 per day, and on an average, lead time is 5 days. So the average demand will be 105 times 5, which is 750. Right, so that's the part. Now we have to calculate the reorder point. So to calculate the reorder point, you have to first do the so if you assume that service level is 95%, you have to calculate the value of z. So again, you do norm.s.inv, you'll get z as 1.645. You have that value, and then you multiply that with the demand during lead time. So demand during lead time will be 5 days times 16 square. So you take the average lead time, multiply that with the standard deviation of demand square. To that you add, I take the average daily demand, you multiply that with the square of the standard deviation of lead time. So you multiply those numbers together, you add them together, you take the square root, and it'll come out to be approximately 154. So you multiply. So actually, I mean, you can take. Let's do this calculation in Excel, right? Let's say. So variable demand and lead time, right? Okay, so make the font bigger. Say average demand. So average demand, average daily demand. Right? Then you have average lead time standard deviation of lead time. Right? So using this, we calculate average demand during lead time and standard deviation of demand during lead time. So remember, DDLT means demand during lead time, right? So we said the average daily demand was 150. Standard deviation was 16. Average lead time was 5 and standard deviation of lead time was 1, right? So with these numbers, we can calculate that the average demand during lead time, so on an average, demand will be the average demand times the average lead time, giving us 750. Now standard deviation, so this is the one. So we have a overall square root, right? So I'm going to put that on the outside, and then you're adding two numbers. What are the two numbers you're adding? First, you're adding your the average lead time times standard deviation of daily demand squared, right? So this lead time times the standard deviation of daily demand squared plus average daily demand squared times the lead time, standard deviation of lead time squared. All right. Now, if you're not comfortable leaving it like this, you can put a parenthesis around this, but you'll end up with the same number. There you go, 154 point, right? We got 154, yeah, 154 point. So, and this, I like, this I'm going to round. You know what, I like rounding up. I'm just going to say round up to 0 decimal places. 155, right? So that's my standard deviation of demand during lead time. And then I can calculate reorder point as these two numbers added together, 750 plus 155 will give me 905. So as soon as you keep an eye on inventory, as soon as inventory reaches 905, you trigger the next order, because during the 5 days, on an average 5 days it takes for the order to arrive. It can be 5 days, 6 days, 7 days, maybe even 3 or 4 days, you don't know. During that time, there is a potential for you to run out of inventory, and so you should hold a safety stock of 155 instead of just the average inventory of 750, which is what you would have held in case there was no variability in demand and in lead time. All right, and that's it. And that is the idea of what happens when demand is variable. So when demand is variable, till the reorder gets triggered, nothing is different, because even if demand is variable, you still have inventory on hand. Once reorder is triggered, now you're in peril, because your inventory is on the way of arriving, but it might not arrive in time. And so instead of just keeping average inventory as, instead of having a reorder point triggered based just on average inventory, you have some extra safety stock so that your reorder gets triggered earlier, and then you are you reduce the peril of being in unit. Oh, I'm so sorry. This is completely wrong. We didn't calculate the. I'm so sorry. So reorder point is wrong. So before we do that, we need the service level. See, don't make this mistake. Damn it. Service level. So service level, let's say, is 95%. Then you would say that reorder point is average demand during lead time plus standard deviation times the norm.s.inv, inverse normal distribution, standard normal distribution of the 95%, and there you go. And that's your reorder point. So, and this has to be rounded. $1,005. That should be reorder point, not 905. Sorry, I forgot the service level part. Yeah. So in this case, they calculated as 1,003 because they approximated this to 154 instead of 155. I like rounding up, so it's slightly more, but otherwise it's very similar. So as soon as your inventory level hits 1,005, you trigger the next order. During that time, you'll likely use up about 750 units of inventory, but there is a possibility that you might use up more. And the reason we are keeping that safety stock on hand is because we want the service level to be 95. Now, let's say that you only use 700 units and the next order arrives, which means that you have 305 units still on inventory, which means that the next time the reorder gets triggered will be later. because you have some extra units on inventory. Reorder always gets triggered at 1005, right? So it might take a week for reorder to get for the reorder to happen. It might take a month for the reorder to happen. Depends upon how quickly inventory is used up. So your extra inventory won't cause that much trouble. It's just it'll add to your holding cost for sure. There'll be some extra holding cost, but not that much. All right. Okay. So I'm gonna end this video here, and yeah, I'll see you all in the next video when we continue with inventory management. Take care.